What's up, my people? In this video, we're going to be talking about logarithms and the properties of logarithms. And let's just get right into it. First thing I want you to remember is that logarithms are inverses of exponents. And we talked about exponent rules. That was in Algebra 1. So let's do a quick review on some exponent rules that's going to come in handy. So remember when one of the exponent rules is if you have x to the a times x to the b, you end up with x to the a plus b. And then if you have x to the a divided by x to the b, you end up with x to the a minus b. And then a couple of other great ones were x to the 0 is 1. Anything to the 0 power is 1. Anything to the 1 power is itself. And then the last one I'm going to point out for right now is, remember we had like x to the negative 2. We're like, I didn't like living upstairs, so we had to move that to the bottom of the fraction that made that positive x squared. Okay? So those are some exponent rules that are very quick. So when we get into the logarithm rules, it'll make a lot more sense. But these are some of the rules we talked about in Algebra 1. Okay? So logarithms are always written log base b to the a. Actually, I'm going to switch that. I'm going to make that a to the b. Log base a to the b is equal to c. Okay? So what will happen is that you'll have to go from logarithms to exponents and sometimes exponents to logarithms. And so what I like to do is I call this the swoosh, which means a to the c power should equal b. Okay, so you literally start here. And then I want to point out your base that's in your logarithm is also your base in your exponent. And then the next thing you write, you do the swoosh, you write your c power, and then this will be your answer. Okay? And we're going to get into some of that here momentarily. Let's see, what else did I want to mention here? I don't think anything yet. Okay, so for example, I did want to mention an example here. So if I were to say, that's what I want to mention before I go there. Anytime we have a log, and let's say there's no base here, it's missing, that base is automatically assumed to be 10. So log of 12 and log base 10 to the 12 mean the same exact thing. When the 10 is not written, it's already implied that it's 10. Okay? Almost like when you're doing exponents and there's no number there, it's already implied that there's a 1. The base 10 implies that the log is already there. The 10 is already there when you're doing logarithms. All right, so let's take a look at this log rule. So let's see what this looks like. So if I have log of 3 to the 9 equals 2. So if I were to rewrite this, 3 squared equals 9. And so that's how that works. And if I wanted to go backwards, I would write that backwards. But I don't think I'm gonna make y'all do that yet. But let's just do it right now anyway. So if I got to go backwards, I will put log base 3. So if I wanted to go backwards, log base 3 to the 9 equals 2. Both swoosh methods work. Okay? All right. So let's get into some of the rules. There are a total of 7 rules. We're going to mainly focus on 3 of them, and then 2 of them are going to be great to know, and we will be referring back to this section up here. Okay? So here we go. Rule 1. Rule 1 says if you have log b to the m times the n, that's going to be equivalent to log b to the m plus log b to the n. Do you notice how multiplication here resulted in addition, and up here multiplication here resulted in addition? Okay, so there's that. That's rule 1. Rule 2. Rule 2 says log to whatever base, if I have m divided by n, that's going to be equivalent to log base b to the m minus log base b to the n. And if you notice, division resulted in subtraction. And if we go back to our exponent rules from up here, division resulted in subtraction. Okay? So far, hopefully that's good. And then rule 3. Actually, before I go into rule 3, no, I'll go ahead and do rule 3, and then I'll do some examples. Rule 3. Rule 3 says log base b to the m raised to the k equals. Now what happens is, I'm going to rewrite this, is what you have to do is we don't really want anything past 2. So when there's a third thing, we just drop it to the front. So that becomes k times log base b to the m. I'm going to do that in black. I'm just rewriting it in black so that it all looks the same. So that becomes k times log base b to the m. Okay, so let's do a couple of examples. Let's do an example of rule 1. So rule 1 example. Let's say I had a question that looked like log 9 times, to the 6 times 11. That ends up becoming log base 9 to the 6 plus log base 9 to the 11. Okay? That's rule 1. Rule 2. If I had log, let's use those same numbers, log base 6, log base 9 to the 6 divided by 11, that's going to be equivalent to log base 9 to the 6 minus log base 9 to the 11. Okay, and finally, rule 3, if I had log base 9 to the 6th raised to the 11, this 11 is going to drop down to the front. That's going to be equal to 11 times log base 9 to the 6th. Okay, so we're just really rewriting all of those. That's rules 1, 2, and 3, and those are their examples. All right, we're going to go into rule number 4. So here are examples. All right, rule 4. Rule 4 simply says log base b to the 1 equals 0. And that makes sense because if we do our swoosh that we talked about earlier today, b to the 0 power equals 1. So anytime you see log of any number and it's a 1 right here, your answer is 0. Okay, that's rule 4. Okay, rule 5 says log base b to itself equals 1. And that makes sense because if I do the swoosh, b to the 1 equals b. And that goes back to these exponent rules where anything to the 0 is 1 and anything to the 1 is itself. So that's where those come in. And then rule number 6 and I'm going to explain this one a little bit. Rule number 6 says log base b to the b to the k equals just k. And that makes sense because remember, when you have the third one, this drops to the front. This becomes k times log base b to the b. And in our rule that we just did, anytime you have a log to the base to that same number, it equals 1. So this actually equals 1. So I actually have k times 1 is just k. So that's why if you have a base raised to itself to another number, it's just that number because they end up canceling out. All right. Sometimes when I'm doing it in class, I'll just cross this out and just leave the k. Okay. So, but I'm gonna let's see if I can do this. There. That's rule 6. And the final rule, rule 7, which we won't use very often, but I'm gonna go ahead and give it to you. Rule 7 is when you have a base and it's raised to the log, that's going to equal just the k. Okay? That's the rule because similar to how these crossed out right here, when you have this same thing happens right there and you just have k. All right. So there's that rule. Let's see. All right. So let's just do a couple of examples. And then we're going to mix some of these rules together. So let's go ahead and do a couple of them. I'm not going to do too many. All right. So let's do the first rule. Let's do a couple. So what if I had log of 3 to the 5? Right now, it would appear that there's nothing we can do. But remember, if I don't have a small base, what goes there? 10. So we actually do have something there. So that 5 is really a third number, equals 5 times log base 3. Now, you don't have to write the 10. Because remember, if you don't write the 10, it's implied that there's a 10 there. Okay? Let's do another one. What if I had log base 2 to the 11 to the 3? That 3 is going to drop down to the front. So I'm going to end up with 3 times log base 2 to the 11. All right. Okay. Now, another thing I want to mention, and I'll go ahead and do it right here. I probably could have did it earlier, but I'll do it right here, is this. Quick review. Remember that the square root of x is equivalent to x to the 1/2 power. The cube root of x is equivalent to x to the 1/3 power. So let's say I were to do an example where I had like log base 3 to the square root of 2. That's really equivalent to saying log base 3 to the 2, that 2 is raised to the 1/2. And then this half is going to drop down here. And I'm left with my log base 3 to the 2. Okay? So there's that little rule. Let's do a couple of them where we have to apply multiple rules. Let's do this one first. Let's do, and you'll have some of these to practice on your homework. We got log of 8 x to the 4th over y, and then that's raised to the 6th. Oh, we got a lot going on here. So how do I tackle this first? Well, first off, my very first thought is that I see the 6 and it's a third thing. So I'm gonna go ahead and drop that first. That's my first thought. Okay. 6 times the log of 8 parenthesis x to the 4th over y. Now I see division, which then leads me to do my other rule where I have to subtract. So this is becoming 6 log of 8 to the x to the 4th minus 6 log of 8 to the y. And then because, here we go again, we have 3 things. This also has to drop. And when that drops, that ends up multiplying. This ends up becoming 24 log 8 to the x minus 6 log 8 to the y. Okay, so that one wasn't too bad. Okay, let's do 2 more. This next one says log of 4 times a to the b to the c to the 4. Multiplication, you should think, oh, that triggers addition. So this ends up becoming log 4 to the a plus log 4 to the b plus log 4 to the c to the 4. Up, that has 3 things. That means this has to drop here. So my final answer is going to be log 4 to the a plus log 4 to the b plus 4 log 4 to the c. That's our final answer for that one. And then our final example for this video is going to be this. What if I had log 5 to the 3 times the cubed root? Actually, I'll make it the square root. The square root of 8 times 7. Whew, that's a lot going on. So I'm going to rewrite it in a way so that everything makes a little bit more sense. So, and some of y'all will be able to do this without looking at all these extra steps, but this will help somebody understand it. So this becomes log of 5. And then in here, I got 3 times the square root, that's a 2 there, 8 times 7. Well, I can rewrite both of those as a square root of 8 times the square root of 7. I can write them separately. And so what this really means is I have log to the 5, 3 times 8 to the 1/2 times 7 to the 1/2. Now, now that I have it all broken down like I want to, I can go ahead and say, okay, this is log 5 cubed times the log of 5 times 8 to the 1/2 times log 5, 7 to the 1/2. And then, as we know, we've done a couple of these already. This is going to drop here. This is going to drop there. So my final answer is going to be log 5 cubed times, not times. The multiplication should trigger addition. So I forgot to switch that. So this is going to become a plus. One half log 5 to the 8 plus 1/2 log 5 to the 7. You may also see the same thing written as this. Because multiplying by 1/2 is equivalent to dividing by 2. So on your homework, if you look at the answer key, you will see it written like the second method, but you know, either one, I typically write it like that. So it's up to you. Hopefully that you watched this video, took all the notes, and if you have any questions, see me in class. Have a good one.